guys, let's get this school year off to a great start, all right? If everything went all right yesterday, then today is Tuesday, August 4th, and I am out today. This is Algebra 2 and Algebra 2 Honors, depending on which period you're in. This is one of my favorite cities in the world, is Paris. And here's our quick announcements, similar to yesterday. Mr. Motes will have tutoring. It usually is Monday, Tuesday, Wednesday. It usually starts about 2 weeks into the school year. So pay attention to that. If you do need questions, of course, I'm your first stop if you have questions about my material, but you can always go to after school tutoring. It is no charge. Normally I'm going to have the lunch schedule for today and tomorrow here and here, but I haven't gotten that just yet. Student packets, please make sure to bring those back by this Friday, 4th, 5th, 6th, 7th, August 7th. Math fee is $5. Please pay that just as soon as possible, as soon as you're able. Chromebooks, make sure you have your Chromebook. You know how to get those. You'll definitely need those today. If you didn't get a book yesterday, please grab a book right over here by the closet. These boxes should have enough books in there for everyone. Grab a Sharpie over here on corner desk and put your name in it. And then we can go from there. That'll be your book for the rest of the, well, for the first half of the year. There's a volume 2 for the second half. If you didn't get a calculator yesterday, please don't grab one because everyone is going to be responsible for their calculator this year. Never ever grab one that isn't yours. Please either use the online calculator, which is linked in Google Classroom, or sit with a friend and borrow somebody's calculator, okay? All right, so for today, we're just starting into a very brief preview of basic concepts in Algebra 1. This is for you folks, and there's at least half of you who just you left Algebra 1 never all that comfortable with what was going on. So we're going to cover very basic stuff, really more like pre-algebra stuff today, and we're going to do a Delta Math today as our assignment, and a very basic. So let me start what's going on here, but please pay attention because if anything in Algebra 1 was a little fuzzy for you, if you're just unsure, if you left there feeling unsure and unsteady about some of the skills there or some of the vocabulary, pay attention to the next 10 or 12 minutes. I always say that and then it ends up being 20. But pay attention, especially to this vocabulary. This vocabulary will be on our first test, which will probably be sometime late next week. Okay, so pay attention to this vocabulary. It's very basic vocabulary. You've been hearing it for 2 years, or 3 or 4 years probably. So everyone should certainly know what a variable is. A variable is just a letter which represents a number. Sometimes your job is to substitute a number in for the variable and solve something. Sometimes your job is to figure out what number that letter represents, depending on whether it's an expression or an equation. And a typical variable is, of course, the classic one is x. That represents just any number. Or we can use y, we can use z, we can use a, b, and c. These are just letters which represent numbers, okay? An algebraic expression is a clump of operations using numbers, which we call coefficients, and variables. So 3x is an algebraic expression. 3x plus 9 is also an algebraic expression. 4x squared minus 3x plus 9 is also an algebraic expression. This one's quadratic. Those of you that might recognize, I know quad means 4, but quadratic is a squared expression. All right, so that's also an algebraic expression. And order of operations, please do pay attention to that. There is a poster right up to my left and your right that shows order of operations. Please excuse my dear Aunt Sally, parentheses, exponents, and so on. One quick note, the M and the D, multiplication and division, you do either one that you get to as you scan from left to right. Addition, subtraction, same thing. You do either one that you get to as you scan from left to right, okay? We'll cover more on that in a minute. All right, here's some more terms for the same sort of thing, okay? You see a lot of terms that are like, is this a monomial or an expression? It's the same thing. A monomial is just a single expression, a little clump of things that are just multiplied together. 2x, 2 times whatever x is. For those of you that think that the if x is 5, that's 25, don't be embarrassed. You're alone right now. You're listening to this by yourself. Just learn, just remember, it's 2 times whatever x is, not 2 and then whatever x is in that place. 3 times y, 3y is 3 times y. 5xy, 5 times x times y. I know you're asking, like, what is x and y? We don't know, so it doesn't matter. 1/2 xy squared. Okay, a binomial, bi meaning two, right? Bicycle has two wheels. So a binomial has two expressions added or subtracted together. Two things, two expressions. So 2x plus 4 is a binomial. It's got two expressions. 2x is a monomial, the 4 is a monomial. Added together, we call that whole expression a binomial. It has two expressions added or subtracted. 3x squared minus 8x, two expressions added or subtracted together. 5x to the third plus 4y, two expressions added or subtracted together. Okay, these are all binomials. That's going to come in very, very handy when we get to factoring, because we're going to talk about binomial squares and how things often factor into binomials. You need to know what a binomial is just like right away. And usually we see binomials in parentheses. A lot of times they're in parentheses. So like this, binomial, right? It doesn't change the meaning of it. It's just a lot of times we use parentheses to separate them from other things that are in the expression. All right, polynomial, more than two monomials added or subtracted together, more than two. If it's two, it's a binomial. If it's three, it's actually a trinomial. I skipped that word here. Tri means three. Poly means more than, usually more than 2 or 3. So 5x to the third plus 4x squared minus 3xy minus 7, that's a polynomial. It has 4 expressions. This monomial here, this one, and this one, and this one, they're all added and subtracted together. That creates a polynomial expression. All right, a couple of quick words that I use all the time that you just need to know immediately. The coefficient is the number in front of a variable that is multiplied by the variable. So that 5 is a coefficient, coefficient on the x. The x is the variable, the y is the variable. The 5 and the 3 are coefficients, they're multiplied by the variable. The 8 is something different. It's just a number like sitting by itself, and that's called a constant term. Just a number that's in either an expression or an equation is just called a constant, okay? So coefficients, variables, constant. All right, quick note. The difference between an expression, an algebraic expression, and an equation, this confuses a lot of students, and it could be you. An expression really has no value by itself unless we know the value of the variables. So let's look at this expression right here. I know it kind of all runs together on the screen here. Let's look at this expression right here. 3zx. And actually it's written wrong. You should always write things in alphabetical order. It should be 3xz, but I created these a couple of years ago, okay? So 3zx, 3 times whatever z is times whatever x is. Now, if I did not know what z and x are, I would have really nothing I could do with that. There's nothing I could do with it. It would just sit there and maybe the directions would ask something else. But in this case, it says, oh, x is 4, z is 4. That means I substitute a 4 in here and a 4 in here, and we multiply all of that together. The final answer would be 48. 3 times 4 is 12, 12 times 4 is 48, okay? 48. So 3 times 4 times 4. That's an expression, and what we did just now is called evaluate. That's just evaluate. That just means find the value of, right? Find the value of that expression. But I could also, if I give you a different value for x and a different value for y, you would get a different evaluation, okay? All right, and then an equation has an equal sign. See that word equal in equation? That word equal means we've got an equal sign that's already in the equation, and that means a lot of times we are supposed to find out what the variable is. We're supposed to solve for x, the kind of classic question in algebra, solve for x. And we're going to talk a little bit more about that. All right, simplifying algebraic expressions. This is something we can do with expressions that doesn't involve solving for the variable. And it doesn't involve evaluating the expression by plugging things in. We're simplifying, okay? So, couple of ways to simplify. We've got distributive property, 3 times x and 3 times 9. So we're going to simplify this to 3x plus 27. we distribute it. Distribute means to give out, right? If I distribute papers, I'm giving out papers all day. So 3x plus 27 would be the distribution of this, and then there's nothing more I can do with that. We're stuck unless I know what x is. If I tell you what x is, then you can solve it. Then you can solve that. But we're not supposed to solve this. It's not an equation. I know what you're thinking, but it has an equal sign. I shouldn't have put the equal sign really, but that simplifies to 3x plus 27, okay? This also, we're going to distribute. You should have your integer facts really well by now. If not, use the calculator, okay? Negative 6 times negative 8, or negative 6 times positive 8 is negative 48x. And then negative 6 times negative 4 is positive 24. So that simplifies to negative 48x plus 24, okay? And then this, there's no parentheses, so there's nothing to distribute. We're combining like terms. The like terms have the same exact variable and the variable letter and the same exponent on the letter, okay? So these are like terms. The like terms are here and here. So I can combine those, and when we combine them, all we do is add or subtract the coefficients. That's that number in front, right? So the 7 plus, I got to include that negative. I know you're thinking it's a minus, but it's also attached to that 3 as a negative. 7x minus 3x is like 7 apples minus 3 apples. We end up with 4 apples. So the x's are simplified. Can I do anything with a 3? No, it's just got to carry on as a 3, and it just has to bring across. So I've simplified that expression now to 4x plus 3, okay? And it doesn't get too much more complicated as we just add expressions, because we just have to identify the like expressions, the like terms. So these are the like terms. They have the same variable and the same exponent on the variable. What's the exponent? It's that little square right there, okay? So I'm gonna simplify this into, I'm gonna put my squared terms first, just because that's the right protocol, right? It's like grammar. So negative 3 minus 5 is negative 8. So negative 8 x squared. I've combined my x squareds now, they're gone. I'm gonna bring my 7x down, and then I'm gonna bring my negative 3 down. Neither of those have a like term to combine with. This one right here, like term, 8 minus 12 is negative 4x. I'm going to put my negative x squared at the front. I know it messes with that one. Negative x squared at the front, and then bring my 13 down, okay? So negative x squared minus 4x plus 13 is how that would simplify. All right, solving equations. Classic algebra, we got to solve equations all the time. We have to solve for variables, either figure out what the variable is or figure out what the expression is in terms of that variable. So we're going to talk about one-step equations, you've been doing this literally since 6th grade. So x plus 6 equals, don't even worry about what's over here, just pay attention to what's happening to the x, okay? What's happening to the x here is 6 is being added to it, right? What's the opposite of addition? We're going to do it to the left side, because what we want to do is take away what's happening to the x. We want to do the opposite to take away what's happening to it. So 6 is happening to it. One of the basic rules of algebra is anything you do to one side of the equal sign, you have to do to the other. So we're going to subtract 6 from both sides, and then we have kind of like vertical equal signs. We're going to bring this down. It's not 11, it's a vertical equal sign. Or you could do this. We're going to bring that down. X plus 6 minus 6 is x. X is now by itself. We've satisfied the equation. X is by itself. And then I'm going to tell you what's under here. What was under here, I can't move that, unfortunately, because what was under here was an 11, okay? So that was an 11. 11 minus 6 then is 5, and we have now solved the equation. But the thinking, the switch in your thinking has to happen with not paying attention to what's over here. Because 99% of you, if you saw x plus 6 equals 11, you could go, oh yeah, that 5 plus 6 is 11. 5 plus 6, I know that. That was easy. But you've got to switch your thinking to this way of thinking, because when the equations get more difficult, you've got to follow this sort of step instead. So we're just undoing whatever's happening to the variable to get the variable by itself, okay? All right, so what's happening to the variable here? It's multiplied by 3. We're going to divide both sides by 3. And our final answer Bring our answer down. X comes down on the left because, why does X come down? Because 3 divided by 3 is 1, and we don't have to write a 1 in front of the X. It becomes invisible. I've got a poster over here with invisible numbers, invisible math. Do pay attention to that. It's going to be posted throughout the year. We don't have to write that 1. 3 over 3 is 1, equals 17. 51 divided by 3 is 17. Here, we've got to subtract 9. Bring our X down. X would equal 33. Here, we're going to add 6 to both sides. Bring our answers down. X equals 33. Notice these are one-step equations. I only have to do one thing to solve them. This is X divided by 4. You'll never see it written like this. I don't like that. You'll see it written like this. And you're all going to, 75% of you are going to freak out like, it's a fraction. I have no idea what to do with a fraction. Yes, you do. You know what to do with a fraction. A fraction is just division. This is X divided by 4. Divided. That fraction bar means divided, and we read it top to bottom, X divided by 4. So we're going to multiply both sides by 4. Once again, the 4's cancel, but they don't really cancel. They turn into a 1, but we don't have to write the 1. It's just an X. That equals 36. Okay? I'm going to move on. Okay, two-step equations. Now we have to do 2 things to solve the equation. We've got this 2x plus 9. This is when you really have to follow these algebra rules because very few people can do that in their head. And certainly not quickly. We can do it quicker by using our algebra rules and not paying so much attention to the 42 at all. We just want to get the x by itself, right? We want to get that x by itself. So we're going to get rid of the 9. You always get rid of constants first. Let's get the variable expression. This is the variable expression right there. Let's get the 2x by itself first by subtracting 9. 2x then equals 33. Now we divide both sides by 2. And I ran out of room, but x is what? 16.5, I think? Yeah, 16.5. Use a calculator. 33 divided by 2. Okay. Now we got 3-step equations. We want to get our variables on one side, our variable expressions on one side, and our constants on the other side, okay? So, we want to get this 3x. I can either add 3x to both sides, and that's going to get rid of it over here. Remember, this is like a dividing line here. This is like the dividing line right here, okay? That equal sign is like a wall. So, you think of it as left side and right side. So I can either get rid of my 3, or I can subtract, I can add 3x to both sides, it'll get rid of it over here and bring it over here. Or I can subtract 2x from both sides, it'll get rid of the 2x over here. I like to keep things positive as much as possible in my room as well as in my math. So we're going to let's add 3x to both sides. What's that going to do? That's going to get rid of it here. Minus 3x plus 3x is 0x, which is not x, just 0. So it goes away. We have 5x plus 9 equals 42. And then we have the 2-step equation from the previous screen. We subtract 9 from both sides, we get 33. We divide by 5. Use your calculator. I think it's 6.2, I think. Okay, you can finish that up. All right, remember that distribute, we already did distribute, means to give out. So if you distribute this, we distribute first. It's one of the earliest things that we do when we're solving a more complex algebra problem. We want to distribute, basically get rid of parentheses, which is also the P, and please excuse my dear Aunt Sally. So negative 18a minus 6b. This also distributes to here and here, but we have to include the negative. It's part of the 3, it's attached to the 3. So minus 18a plus 24c. Now we've got some like terms. What are our like terms? Our like terms are the 18a and the 18a, and they're both negative. Negative 18 minus 18 is negative 36, okay? I'm sorry, I'm gonna bring my answer up here because I've run out of room down there. So negative 36a combines those two. Now let's combine our, what's a good color? Maybe that. Minus 6b plus 24c. Oh, those aren't like terms. I shouldn't have circled them. They just get stuck on the end here, like this. They're not like terms. They don't have the same variable. I'm done. Okay? right, so when you're solving a more complex algebraic equation, this is probably a 4-step equation, maybe 5. You follow a standard rule, standard list of procedures. It's a little bit like the order of operations, but it's to solve equations. So let's follow this steps to solving a multi-step equation. First step, distribute. We get rid of our parentheses by distributing, so we're going to end up with 12n plus 32 equals, and then I'm just going to bring the right side of the equation down because there's nothing to simplify, no parentheses. Now, combine like terms on each side. I don't have any like terms on the left, and I don't have any like terms on the right, so I can skip step 2. There's no like terms on each side to combine. Move variables to one side. That I need to do. I've got n's on the left and n's on the right, but I need them on the same side of the equal sign. So I like to keep things positive, so let's subtract n from both sides. Subtract 10n, I bring my answer down. 12n minus 10n is 2n plus 32 equals 20. By the way, I make little careless mistakes all the time, just like you do. I always check my answer at the end. That's your fail-safe to make sure that you didn't make a careless mistake or didn't make a little calculator error. So if I make a careless mistake and it's driving you insane, try to put that out of your mind. We'll clear it up at the end. Or you can tell me when I get back on Monday. All right, so we're going to subtract 32 from both sides now because now we've got our variables to both sides. We've distributed. We didn't have to do this. We've got our variables on one side. All of our n's are combined on the left now. Now we move our constants to the other side. Remember, a constant is just a number. Just a number that's not attached to any variables, not multiplied by anything. It's just a number. So now we're going to subtract 32 from both sides. And now I bring my 2n down. The 32's cancel. That was the whole point of subtracting 32, right? So 2n comes down and negative 12 is left over here. Simple one-step equation left. I can divide both sides by 2. And n is negative 6. Now, remember I said we need to check our answer. It's always a good idea to check your answer, especially on a test or a quiz, anything that counts a lot. The ACT, the EOC. These are things that you want to really check your answer, okay? So let's check our answer. Let's just check it by plugging it back in, right? We're going to take that thing and just put it here and here. And then I have to, of course, delete that. So negative 4 times negative 3 times negative 6 is 18. 18 times 8 is 10, okay? 10 times negative 8 is negative 60. 10 times negative 6, sorry. 10 times negative 6 is negative 60 plus 20. This equals negative 40, that equals negative 40. We are good. Okay, solved it. All right, here we are with the most important skill of all of these skills for what you're about to dive into Algebra 2. Okay, if you look around the room, all of the posters around the room, the ones that are about this size, the 16 by 20s or whatever, they show different types of functions. This is functional notation. You're going to be seeing this all year, so please pay attention. This is the most basic form of it, and you studied this in Algebra 1, but it's been a whole year since you saw it, okay? All right, so a couple of things. We've got a function up here. We have rewritten the function. Now see this is functional notation. The f, by the way, is just sort of the name of the function. It's not a variable. It's the function called f in terms of x equals 3x minus 2. Okay. So the value of the function depends on whatever we plug in for x. I can plug 1 in for x. I can plug 5 in for x. I can plug negative 3.14 in for x. I can plug anything in for x, and it changes the value of the function because when I plug that in for x, I multiply it by 3 and subtract 2. There's the value of the function. That gives me two values to work with. The value of x that I plugged in, and the value of the function based on that value of x. Guess what that forms? An ordered pair. I can form all sorts of ordered pairs by plugging in different values of x and graph the ordered pairs on our good old coordinate plane. And there's graphing paper over here, by the way. And then you're golden. You have graphed a function. And it doesn't matter if it's a quadratic function or a square root function or a polynomial function or an absolute value, they all follow this same pattern. We learn some patterns to do them quicker. We learn about vertex, and we learn about slope, and we learn about lots of different things, intercepts, terms, but you can always back up to this, okay? So I did replace the f of x with y. It's not quite this, it is the same thing, it represents the same thing. This is graphing notation with an x and a y. This is functional notation, but it really kind of means the same thing, okay? So, real quick, a graph is simply connect the dots for those solution sets. It's a connect the dots. We're going to create some solution sets. By solution sets, I just mean we're going to plug in some values of x, solve, get a value of y, which corresponds to that value of x. That gives us a bunch of points, a bunch of dots. When we connect the dots, we will have graphed that function. This is absolutely the thing that we're going to be doing all year, so please pay attention to this. So let's choose some numbers for x. I don't want to choose 10 million. I don't want to choose negative 5,500. These are two big numbers. See, my graph only goes to 4. Let's choose like negative 2, negative 1, 0, 1, and 2. Okay, let's keep it close. So negative 2, negative 1, 0, 1, and 2. Why can I plug anything in for x? Because it's an independent variable. It can do whatever it wants. Y changes depending on what x is. Let's see how. When I plug a negative 2 in here, I get negative 6. Negative 6 times negative 2, negative 8. Negative 3 minus 2 is negative 5. This is negative 2. This is 1. And this is 4. Okay? How do I get this? I plug this value in for x, multiplied by 3 and subtracted 2. Just 2 operations. I did it all in my head so I can move quickly. So let's graph all of these. Negative 2, negative 8. That's going to be that's going to be way off. I'm going to stick with these 3 right here. These are the only ones I'm going to really be able to graph here. So that one goes negative 1 down here. Negative 5 is down here. 0, negative 2 is here. 1, 1 is here. 2, 4 is here. So I actually did these 3, okay? Because the other ones were off the chart a little bit. And that gives me the graph of this function. Okay? That's that function. That's the graph of this function. And by the way, every single point on that line, every single little dot on that line creates an ordered pair. That ordered pair, that x and y ordered pair, will solve that function. And by solve, I mean if we plug the x into the x and the y into the y, it makes it true. It makes it equal on both sides. Every single point on that line. This is a linear equation. The linear function is right back in the corner with the train on it. And that is the basis for so much of what we're going to do this year. Understanding that we can create a graph using a table of values, and that graph is every single ordered pair that matches the function, that makes the function true, solves the function, okay? All right, so I'm going to add one more video, but I think I've gone long enough. These file sizes get a little bit large, so I'll upload this one when I get home, and then I'm going to do another one to show you the delta math that we're about to do. So there's going to be a part 2 for today. Watch the delta math one next, and you'll know what to do on the delta math, okay? But here it is. Join our class, the delta math. The codes are up here in the corner, but they're also posted on Google Classroom. There's even just a link that should work. You should be able to just click on your class on the link in Google Classroom on the main page that just shows all of the announcements. And we're going to do one called Algebra 1 Review. It's everything that we just covered. All of my homeworks are due, the homework or classwork. You'll rarely have homework. I give you enough time in class to complete almost everything. And not everything, but almost everything. And everything's due to the next day, okay? All right, so I'm gonna stop this video now, and we will, and I'll cover the delta math next, okay? Thanks for listening.